going to be solving it using inverse of a matrix in solution. Though there are other methods to solve it, especially when the simultaneous equation is a 3 by 3 matrix. It becomes easier, but nonetheless, we're going to be limiting ourselves to inverse of a matrix. Afterwards, on simultaneous equation with basically two variables, say x and y. So we'll take one example, and perhaps I may have to augment it with Crammer's rule, solving the same question of Crammer's rule. The method are not different. One example is enough to solve 1,000 question the moment you understand it very well. So we'll take an example on inverse method. Yes, inverse method to solving inverse method of matrix. You get matrices. You get the gist. So you know what we call system of equation, where we have, let us say that I have A, or let me say I have an equation, say A11 x1 plus A12 x2, then I have A21 x1 and then plus A22 x2. Let us say it's equals to, let's say it's equals to B1 and equals to B2, equation 1, then equation 1 to equation 2. Yes, this is just like a model to that question. And the coefficient of x1 here is A11, that of x2 is A12, that of x1 on the second equation is A21, and x2 on the second equation is A22. While the constant is B1, B2 on equation 1 and 2 respectively. So I'm going to factor out the coefficient of x1 and x2 from both equations. So I have A11, then I have A21, then I have A12, then I have A22, then I have x1, then x2, and that is equals to my constant B1 and B2. Then what do you observe? You observe something very significant here. We have been able to crop out our coefficient of x1 and x2 from both equation 2, and what we are looking for is our variable x1 and x2. They have our constant b1 and b2, which the equation sums up to. Do you understand? So that being said, we can represent the whole of this as capital A, the whole of this as capital X, and the whole of this as Y or B. As the case may be, it is not rigid, it's just a dummy variable. So what's the next step? The next step is for me to find the inverse of my what? Of my A, and recall that the inverse of A is simply equals to A inverse equals to the adjoint of matrix A all over the what? The determinant of matrix A. But I've done that in our recent classes, so that's what I left actually. So I'm going to multiply both sides by the inverse of matrix A. So I'll say A inverse multiplied by A times X equals to A inverse multiplied by B. So A inverse times A will give me an identity matrix A, then multiplied by X, and that will be equals to A inverse and B. And this will be my answer eventually. I know this may look like Greek or may look Hebrewish, but as we take one example, it becomes very clear. But it's just very, very necessary for us to understand how all of this model works. And the way it's being understood, we can easily find our way around any other question as the case may be. Then let me just divide it like this. This is for inverse method. Okay, maybe for the sake of very, very good comprehension and so now separate videos, let's also talk about what we call the Crammer's method, the Crammer's rule of solving. The Crammer's method, the Crammer's rule of solving simultaneous equation. Do you understand? Of solving simultaneous equation. So the same stuff, the same system of equation, x1, a12 x2, a21 x1, a22 x2 equals to b1 equals to b2. Crop out the coefficients a11, a12, a21, a22, x1, x2, then b1, b2. Do you understand what I'm trying to do? This is the system of equation. Then, what we are doing with Crammer's rule, the concept behind it is that this my x1 is simply equals to my what? Maybe if I go there, let me just tell you that The first thing I'm going to do is that I'm going to find the determinant of the main determinant. I call it main determinant. So we call it like a triangle. The main determinant, then and the main determinant is the what? Is the determinant of matrix of my main coefficient 2, 1, then 2, 2. Do you understand? And how do I solve for that? Plus or minus, I cross multiply. Like I said, all these have been done in a previous video. I only try to apply it as it were. So in case you do not understand how we're doing this, kindly make reference to the former videos. So I have this multiplied by this, I will have A11, A22 minus this times this, A12, then A22. I will then go to my first determinant. Yes, I can call this one delta naught, as basically then delta 1. Then I'll go again. I will use this my constant to represent my first column here. So it becomes B1, then B2, then I just replace it, write A12 and A22. I will do the same by finding the determinant. Then it becomes what? It becomes B1, then A22 minus B2, then A12. This times this, then this times this, then I have my determinant. Then followed by my second determinant, which, what will I do? I will replace my first column A11, then A21, then I will bring this my constant to the second column, so I will have B1, then B2, then it becomes what? Cross multiply. Then I have A11, B2, then A21, B1, eventually, and that becomes my determinant. Meanwhile, I need to spell it out again that if it was not a square matrix, and the square matrix is a matrix that has equal number of rows to be the number of column 2, 3 by 3, 2 by 2, 1 by 1, 4 by 4, they are called square matrix. If it is not, we cannot solve for the determinant of a matrix that is not a square matrix, because that will be kept to us. So I will then say that in that case, my x1 is equals to the first determinant over main determinant, then my x2 is equals to second determinant over main determinant. And that is the blueprint to solving for x and y using either the inverse method or the Crammer's method, either of the two subtype or plane. Now, this is in addition to the method you have already known when you are in SS3 class or the junior class. You are told that there are basically 3 methods to solving simultaneous equation. The first method, which includes the elimination method, followed by the substitution method, then the graphical method. Now I'm bringing another one to your corridor now, that is called the matrix method. Though under the matrix method, you can discuss 3 other methods, which is called the inverse method of the matrix, then followed by the Crammer's method, then the Cyrus method. But we are focusing on 2 today, which is simply the inverse method of the matrix, then the Crammer's method, and these are the blueprints. So the next thing in line is to look at an example that we can do to satisfy all of this stuff. 1 is enough, but if I'm excited, you can do 2. Then you can have a class work to do for yourself. So just go on as I go on, follow me as I go in the class. Let's take, like I said, I'm going to take an example to solidify a point and bring home all our thoughts all the way. Look at the example for instance. Solve this equation, solve the following equation, solve the following simultaneous equation using inverse method of the matrix and Crammer's method. So let's look upon this. See number 1. Let's say I have 2x minus 3y, and let's say it's equals to 1. And let's say I have 3x. Let's say I have 4y. And let's say it's equals to 10. You understand? And let's say we have number 2. And for instance, let's say we have it to be 3x plus 2y, then we say it's equals to, let's say we have it equals to 1, then I have 4x plus 5y, Do you understand? Let's say I have this equals to minus 1. Then this equation 1, equation 2, equation 1, equation 2. Like I said initially, I am going to be focused on one mainly. But if I see a need to do number 2, I will. But let's see number 1. Look at using inverse method first. All you need to do is to follow process dogmatically. That's your lifeline. That's your assurance. Nothing more. You need not to cram any of those steps. All you need to is, after this step, what is the next? If you can understand and get yourself familiar with those steps, you are very good already. So let's see how it goes. So I'm going to be following my model. If you have it written down somewhere, follow it the same way as well. So solution. Solution. I have 2x minus 3y equals to 1. And I have 3x plus 4y equals to 10. I have it to equation 1, equation 2. What's my first method? Let me crop out the coefficient that is embedded here. What is the coefficient of x here? 2. Of y here? Minus 3. Of x here? 3. Of y here? 4. Close it up. That was the first thing I did in that my model. Then, followed by, bring back my x and bring back my y. Then, followed by my constants 1 and 10. That's your first step. There's no need to cram anything. Just follow the way I'm doing it. Then you'll be very, very fine. Now look out next. My next job is this my A. I call it my matrix A like I did initially, which is what? 2, 3, minus 3, and 4. Then my first next one is to solve for my determinant of the matrix. Plus, minus, then just put a cross like this, so that the determinant of matrix A becomes 2 times 4. Then followed by what? Minus is here, I put it here. Then 3 times minus 3. 3 times minus 3. So it becomes 8 minus 9, and that's equals to 8 plus 9, and that's 17 eventually. So I have 17 there. Obviously, 8 is there, then I have 17. So if that's the case, the next thing for me to look for the adjoint of my matrix, what matrix A. Very easy to find to somebody adjoint of a 2 by 2 matrix. What do? I'm going to exchange these two numbers that is on the main diagonal. 4 will come here, 2 will come here. So I'll put 4 here, I put 2 here. Then I'll multiply these other two numbers with a minus minus. So minus times 3 is minus 3. Minus times minus 3 is simply 3. Then I close it up. Then do not forget that the inverse of a matrix is given as the adjoint of A all over the what? All over the determinant of matrix A. So in other words, what is my adjoint of A? 17. So that's number 17. Then I write this beside it, called 4, 3, minus 3, and 2 eventually. So this becomes the inverse of my matrix A. And don't forget from what I said that here is A, here is my x, and here is my y, or b, as it is B. Let me just make it b, so I will not have to confuse you. So multiply both sides, by the inverse. So that if I say A inverse times A times x, it will give me A inverse times b. What does that mean? It's a law, it's proving that A inverse times A will give me I, which is called identity matrix. It's also there. It's also obtainable in the recent video that we did. The last video we did right now. So that eventually, what does this imply? It implies that this becomes x, and my x is simply what? My x is simply x, y. Then my A inverse here is 1 over 17. Open the bracket. I have 4 minus 3, 3, then 2. That's my inverse. Then my B, which is my constant, 1 and 10. 1 and 10. So next is to multiply, which we have also done before, the multiplication of matrix. So 1 over 17, row times column, 4 times 1, plus 3 times what? 3 times 10. Minus 3 times 1, plus 2 times 10. 2 times 10. So what does it give us? It gives us 1 over 17, 4 plus 30, minus 3 plus 20. So it gives us up eventually 1 over 17, 34 and 17. So I have my x and y here. So my x and y here gives me, this is a constant, multiplied by each of these. it becomes 34/17, then 17/17. So what to that give us eventually? So xy then becomes 2 and y. Therefore, x equals to 2 and y equals to 1. That is how smooth and slick it can be. It's very smooth because you understand the process of how things run. So you move from cropping out the coefficients to writing out the variables, then the constant, then you remember your system of equation, you find your determinant of the matrix, you find the adjoint, you remember the formula for your inverse of the matrix A, you apply it, multiply this by A inverse, then you do as you have said, then you give your answer. This is applicable to any question you can think of, the way to understand the process of flow. So let's apply Crammer's rule for the same question. Let's see if we have the same x and y value to be 2 and 1 like we have there. So step with and follow. So let's quickly apply the Crammer's method. And I would like to have a comment which of the method you think is more easier, though the two must be known. So let's see. We have the same way, prop out the coefficient of the variables in the equation. I have 2, I have -3, I have 3, I have 4, then I have my x, I have my y, then I have my 1, I have my 10. My first job is to solve for my main determinant. My main determinant is what? Delta naught, and that is what? That is simply 2, 3, -3, 4, plus, minus. Do this for it. So my determinant becomes 2 times what? Times 4, minus here, 3 times -3, 3 times -3, and that is what? 8 minus -9, and that is what? 8 plus 9, and that is what? 17. That's my main determinant. Then I'll go to my first determinant, delta 1, which means I'm going to take my 1 term, I'll put it on the first column, being the first determinant, and I'll take away 2 and 3. So I have 1, 10, -3, and 4. The same way. I put a plus, I put a minus, the same way I did for the first one. So my first determinant then becomes open bracket 1 times 4, then minus which is on the top, then 10 times -3. 1 times 4 is 4, minus 30, and that is 4 minus plus 30, and that is 34 eventually. Then next is my second determinant, which I will write as delta 2. How is it done? I'm going to take my constant and put it on the second column while I will do the fix this way. So I have 2, 3, 1, 10, plus, minus, then my delta 2 is equals to 2 times 10 minus 3 times 1. So delta 2 is equals to 20 minus what? 3. Good. So delta 2 is equals to 17 eventually. Do not forget that our x is equals to delta 1 over delta naught, which is the determinant. Also, my y is my delta 2 over delta naught. So x equals to, what's my delta 1? My delta 1 is simply 34, and my main delta is 17, and my y, delta 2 is 17, then the main delta is also 17. When I slash it out, x equals to, and what? And y is equals to 1, eventually. So, what do you observe? The first one will have the same answer, and the second two will have the same answer. And I assure you once again that if you have gone through the same method that I have done and apply it to any question you can find, you have the same answer for the two methods. And the strength of mathematics is in its practice. When you have done one, try another, until you master it. The moment you can do that, you are going to do very well. So please keep this example to heart. I think I'm not meant to do it. It's just something you can try for yourself, and if you try it, which I encourage you to do, drop your answer in the comment section. I would like to see them. Thank you so much for being a part of this class. I wait to the next video. Do well to subscribe and turn on your notification bell so that you can be alerted when a new video is uploaded.